We're going to continue our work with shortcuts for the chain rule here. This time we're going to talk about exponential functions. So if we have a function that looks like y equals e to the u power, where u is some function of x that we'll just call g of x for right now, then the derivative of this function, y prime, well, the derivative of e to the u, I would expect that to look a lot like e to the x. So the derivative of e to the u would be e to the u, but remember that u is a function of x. I actually have a composition of functions, which means we need to use the chain rule, and the chain rule says we need to multiply by that inside function, which is u prime. So we can leave it right here. I do like to rewrite this one because it can be kind of confusing about, is this u prime a part of your exponent, particularly if you don't have great handwriting. It can just be a little bit unclear. So to avoid any potential confusion, I like to take that u prime and just bump it up to the front of my function, since I can multiply in any order I want. So I'm going to rewrite this as u prime times e to the u. I think this is a much nicer way to write that form, that derivative, and it just avoids any confusion that we might run into. So we'll look at a couple of examples here. In our first problem, we've got y equals e to the 2x plus 5 power. When you're working with exponentials, if this power of e is anything more complicated than just x, if it's 2x or x squared or x cubed, whatever it is, if it's anything more complicated than just x, then we're going to have to use the chain rule. So that's kind of what tells me, hey, we're going to have to use the chain rule here. And when we use the chain rule on exponential functions, we're always going to take that power to be that, quote, inside function u. So we have y equals e to the u. So if I kind of look at what the derivative is going to look like, I'm going to take the derivative of my power, so y prime, derivative of 2x plus 5, that would just be 2, times, so right now I've got u prime, I need to multiply that by e to the u power. So I need to multiply that by e to the 2x plus 5 power. So I'll have 2 times e to the 2x plus 5 power. And there's my derivative. Not really any more simplifying I can do there, and I would just stop right there. So exponentials can be really nice with this derivative rule. I think it speeds up the process of using the chain rule quite a bit. If you don't like this, if you want to continue to use that 4-step method, again, please continue to do that. You're absolutely, you're not going to get any problems wrong for not using this shortcut. It's just there if you want it. Let's look at one more example here. This time I've got y equals 4 times e to the x squared minus 5x plus 9 power. So here I'm looking at this power. I'm going to take x squared minus 5x plus 9 to be my, quote, inside function. So we said if you have y equals e to the u, our shortcut derivative rule would be u prime times e to the u. Here we've got this constant multiple of 4. That's not really going to do anything. That just comes down with us to the next step. We just bring that down. So we multiply our derivative by 4. So we're going to have 4 times, first we need u prime, so we need the derivative of our power. So that's going to be 2x minus 5. And then we multiply u prime by e to the u. So e to the x squared minus 5x plus 9 power. So e to the x squared minus 5x plus 9 power. And honestly, if you wanted to leave your answer right there and stop and be done, you could absolutely do that. If you wanted to distribute this 4, you could also do that as well. You could say, well, that's 8x minus 20 times e to the x squared minus 5x plus 9. Either one of those I think is perfectly fine. But yeah, there we have our derivative. So I do think that these exponential functions in particular can be really, really quick if we use this shortcut, which is why I really like to show it and to use it in this course.